Hi everyone, we are back from winter break, and now we are starting the new year off with another math video. And Alexa's gonna start us off with multiplying binomials.
Hey everyone. So we'll start with multiplying binomials, and a binomial is any expression that has two terms in it. So for example, something like maybe 2x plus 2, since 2x is a term and 2 is a term, or maybe even 2x squared plus y. This would also be a binomial. And how do we multiply the two together? So to start, let's look at a very simple binomial that's not made up of any variables, just numbers, and see how that works out. And at the start, you might make the mistake of multiplying the terms in order. So for example, 2 by 3, and then add 4 by 2. And this would actually not be correct, because if we do that, we would get 6 plus 8, 14, which is obviously not the answer to this. The answer to this is 30. So the way to properly multiply them, or to see how to properly multiply them, we can use this thing called an area model. And what we can do is we can use the fact that the area of a square is the multiplication of its sides, or not of a square, but of a rectangle. And if we label each side as one of the terms, then we can use that to find the area of the whole square, which will give us our answer. So for example, we can take this rectangle and split this side into two parts. The first part is for the 2, the second part is for the 4. And then we can do the same thing for the 3 and the 2. And now we can just multiply out the parts. And I guess what's useful to notice is that there's a secret plus before every number that we obviously don't include because numbers are just positive. But anyways, let's multiply them out. So we know that 2 times 3 is 6. We know that this is 12, 3 times 4. 2 times 2 is 4. And then 2 times 4 is 8. So now we know the area of the 4 smaller rectangles that were made, and to find the area of the larger rectangle, we can just add all of these together, and when we do that, we would get 30, which is our answer. So the key thing to notice here is, one, is that we're splitting each side into two parts, a part for each term, and in this way, we have 4 new rectangles that are formed, and then we know the length of the sides of each rectangle. It's just important that you pay attention to which length you're taking. So here, for example, for this rectangle, we're taking we know that it's going to be this length, which we know is the second term 4, and we know that this length is the first term from here, 3. So let's move on to examples which are a little bit harder, actually involve variables. So for example, our first example is x plus 3 and 2x minus 2. So I made an area model right here in the bottom right corner. So again, we do the same thing. We get our rectangle, split it into 4 parts, each side into 2 parts, and we have a term for each part. So we can put 2x minus 2 on the top or on the side, it doesn't matter. So let's put it on the top. So we have a 2x and then a minus 2. And it's important that you make this negative 2 because it is minus 2. And for the other side, we have x plus 3. So we have an x for one side and a 3 for another side. Okay, wait, can you actually give me a second? So I'm not gonna go. All right, sorry.
Okay,
Okay, so I can continue from where I left off, right?
yeah, go ahead.
Okay. Yeah, and then this 3 is positive because it's x plus 3. So anyways, let's calculate the areas. So we know that 2x times x for this rectangle will be 2x squared. We know that negative 2 times x for this rectangle will be negative 2x. We know that 2x times 3 for this rectangle will be 6x. And we know that negative 2 times 3 will be negative 6. And now for the final step, we just add the terms. So in this case, our terms are 2x squared plus negative 2x, which is just minus 2x, plus 6x, which is just 6x, and then minus 6. We can combine these two terms into 2x squared, just plus 4x, and then minus 6. And we can't really further simplify anything, so that's our answer. Now let's look at a third example, just to make sure that you guys understand it. So in this case, it's 2x plus 3 and times 3x plus 4. So we do the same thing, split it up into 4 parts, 2 parts per side, and put the terms on each part. So 3x plus 4, 2x plus 3. Let's multiply it out. So 6x squared for this rectangle, 8x for this, 9x for this, and 12 for this. Now we can add it all together, and I'll just combine these two right away. And our answer will be 6x squared plus 17x plus 12. Okay, so that's how we multiply binomials. However, you might also notice that once you do this for a while, you may find yourself, instead of drawing out the whole rectangle, just doing it in your head. And let me quickly show how to do it in your head, if you would like. However, it's really useful to start with rectangles, or to even check your answer with rectangles, because it's much easier to see. So let's look at this problem again. 2x plus 3 times 3x plus 4. What we can notice is that this 2x will be multiplied. So if we look at the rectangle real quick, we notice that the 2x is multiplied by both the 3x and also by the plus 4. So we can do this. We can multiply 2x by the 3x and also by the 4. And then we notice that the 3 is also multiplied by both the 3x and plus 4. So we can also multiply the 3 by the 3x and the 3 by the 4. And after we do this, we can just write out what we get, which would be these 4 terms. And then adding them together would give us our answer again. So yeah, that is how you multiply binomials.
The next thing we're going to go over is the multiple methods for solving. And then there are 3 according to CPM, which is rewriting, looking inside, and then undoing. So to go over what each of these basically do, rewriting is just, rewriting the formula so it works out or it's easier to solve, or moving it around from alternating sides of the equal symbol. And then looking inside is basically just simplifying something, or looking inside a bracket, a larger number, a square root, and seeing how that can help you. And then undoing is simplifying, except basically using so simple multiplication or simple arithmetic, addition and subtraction, to basically simplify the equation so it's easier for you. And then, so we will start off with rewriting. So our first question is x over 2 plus x over 5 equals 3. So we notice that 2 and 5 are denominators here, and they are not the same. So to fix that problem, we have to think about what is their common, what thing do we have to multiply the entire equation to get rid of 2 and 5. And that would be their least common multiple, which is 10. So we go to here. If we multiply x over 2 times 10, then we get 5x. And if we go to multiply x over 5 by 10, we get 2x. So we get 3, and make sure to multiply both sides. So we get 5x plus 2x equals 30, 7x equals 30, and then x equals 30 over 7. And then that cannot be simplified, so x equals 30 over 7 is our answer. The next thing is a binomial, so multiplying binomials question. So we have x minus 3 times x minus 6 equals x squared minus 12x minus 6. So going off of what Oleg said about how you can multiply binomials without boxes, we're just going to take this like that. So you multiply x by x, and then x by negative 6, negative 3 by x, and negative 3 by negative 6. So we're going to get x squared minus 6x minus 3x, and then negative 3 times negative 6 is positive 18, which equals x squared minus 12x minus 6. So from here, we want to simplify this so we can focus in on just one single x. So we have x squared minus 9x plus 18 equals x squared minus 12x minus 6. So we can subtract x squared from both sides and then subtract, we'll just go with that. Okay, so 9x plus 18 equals negative 12x minus 6. We can move the negative 12x to this side, and then we can move the 18 to this side. So negative 9x plus 12x will give us 3x, and then negative 6 minus 18 will get us, negative 24. And then divide everything by 3, and we will get x equals negative 8. And that is our answer. Okay, I'm going to draw a little barrier here so we don't confuse these two questions. Okay. So next is looking inside, which is basically looking inside a larger number, like I said before. So we have 3 to the power of x plus 3 equals 27. So looking inside, we can see that 27 is another power of 3. So how do we factor 27? Is 3, 9, and then 3, 3. So we have 3 3s. So how we're going to simplify this is 3 to the power of x plus 3 equals 3 to the power of 3, which is the same thing as 27. And if you notice, what we're trying to find here now is how we make these powers equal each other, because our base is the same. So we can just focus in on these numbers. So x plus 3 equals 3. How will we make that happen? So x in this case would have to be 0. And if we look back to the bigger problem, 3, 0 plus 3 equals 3 to the power of 3, which equals, so it's correct. And then our second question is 3 times 2x minus 7 equals negative 21. Oh, negative 21. So looking inside, let's say the bigger number, we have 3, 2x minus 7, and then how should we factor 21? If you know 21, or negative 21, is the same thing as, you can factor it 3, 7, but one number has to be negative. So in this case, because we have a 3 here, we want it to be equal. So we have 3 and we have negative 7. Just like this example over here, we know that the base number, or one number that we're going to multiply, is the same. So what we focus on is 2x minus 7 equals negative 7. Another way to think about this is that you divide this equation by 3, which leaves you with this equation. So from here, 2x equals negative 7 plus 7. In this case, 2x equals 0, and x equals 0. Yeah. Okay. And then finally, we have undoing, which is simplifying the equation using addition, subtraction, or multiplication. So first thing for undoing, we have this 1, which is just sticking out right there. And we want to have the variables on one side, and we always have to have the numbers, the values on the other side. So we subtract 1 from both sides, 7 minus 1, which equals, 7 minus 1, which equals 6. And then we have 2/3 x equals 6. If we multiply both sides by 3 over 2, we'll get x equals 6 times 3 over 2, which is the same thing as, if you cross this out, you get 3. 3 times 3 is 9. So x equals 9. And then, second question, 10 minus, and in a bracket, x plus 7 equals 5. So from here, let's see, we want our variables on one side and then our whole numbers on the other side. So we get negative x plus 7, and then we're subtracting 10 from both sides. So 5 minus 10. We get negative x plus 7 equals negative 5. And if you notice, we have both. Well, you don't have to do this, but this is just to make things easier for you. You see a negative on both sides, so we could multiply by another negative 1. We'll get x plus 7 equals 5, because negative is a positive. And subtracting 7 from both sides, we get x equals negative 2. And that's it.